So let's talk about solving trigonometric equations that require factoring. So you can see we have a variety of equations in these four problems. This is T5 that we need to solve. Now, if we look at this question A, you can see that it's sort of in a quadratic form. There's something squared and then something by itself and then a constant term. So I'm going to do this once. I'm not going to do this every problem, but let's say I let m equal sine x. Then that means the equation I'm trying to solve would be 4m squared plus 4m plus 1 equals 0. That's basically a quadratic that I could solve by factoring, right? And that would factor as 2m plus 1. 2m plus 1 equals 0. But my m was sine x. So it's 2 sine x plus 1 equals 0. Now, I typically, when I'm doing this, don't do that substitution step, and I'll jump straight from there to there, but your mileage may vary. So now I can use the zero product property. Now, since each of these factors are the same, I'm not going to write the same thing twice. But 2 sine x plus 1 would have to equal 0. So then we're going to get the trig thing by itself. So sine x would have to equal negative 1/2. And then we think of the unit circle, where does sine equal negative 1/2? So let's see, sine is the y value. So that would be at 7 pi over 6 and at 11 pi over 6. But since they were looking for all real solutions, we need to add 2 pi n, where n is an integer, because every rotation of 2 pi would land me right back at the same value. So the next problem, I'm going to do this one without doing that substitution step. So if I have cosine squared x minus cosine x equals 0, this is quadratic, but it has a common factor. I can actually pull out a cosine x, then use the zero product property. Places on the unit circle where cosine is 0 is pi over 2 and 3 pi over 2. That would happen again every 2 pi. Now on this, because pi over 2 and 3 pi over 2 are separated by pi, you could just write pi over 2 plus pi n, and that would be okay. But either one of these is fine. This is more like what we've been doing on the other ones. So then I need to know where cosine x equals 1. Well, that happens basically at 0, right? It doesn't happen at pi because it's negative 1 there. Plus 2 pi n, where n is an integer. So these would be the values of my answer. So if I look at question C, again, I can pull out a common factor. Use the zero product property. Need a place in the unit circle where sine x equals 0, so that would happen at 0, and at pi, and at 2 pi. So it happens at 0 plus 2 pi n. Nope, sorry, 0 plus pi n. So like I said on the last problem, I could have written it as just plus pi n. I could do the same thing here. And then for the cosine x minus sine x equals 0, that's going to happen when cosine equals sine. So you have to think of the unit circle and think about where they're equal to each other. And that happens at pi over 4 plus 2 pi n. I don't have enough room. And then it also happens at 5 pi over 4, where they're both negative root 2 over 2. So that would be the answer on those. So if I look really quickly at part D, I wanted to make sure I actually had room on the screen before I did this one. I like this one because you just look at the equation, you say, well, there's something suspicious here. That left-hand side has an x plus 3 in it, but there's a tangent in there, right? So I need to pull a tangent out. Now, you might be really tempted at that point to divide both sides by x plus 3. Do not do that. Whenever you divide by something that could equal 0, you're actually eliminating a solution. And so you would not have all the solutions that you could possibly have. What we're going to do instead is we're going to take tangent of x And we're going to move this thing over as a whole. Subtract it from both sides. And then I'm going to factor an x plus 3 out of that. Never divide by something that could equal 0. Always factor it out. So then I'd have x plus 3 equals 0, so x is negative 3. And then I'd have tangent of x minus 1 equals 0, so tangent of x is equal to 1. That's really messy, sorry. And although you don't necessarily have like the values of tangent on the unit circle memorized, tangent would equal 1. Again, where sine and cosine equal each other. So that's going to be the same answers as what we had for the second part of part C, which is pi over 4 and 5 pi over 4 plus 2 pi n, where n is an integer. There we go.